In section 3.8, we're going to be factoring some special polynomials. And before we get into what these polynomials are, let's take a look at these two examples. If I was asking you to factor x squared minus 16, this would be the same thing as factoring x squared minus 0x minus 16. So again, using our factoring skills from simple trinomials, what two numbers multiply to give me negative 16 and add to give me 0? Well, I'm hoping you'd find out that that would be x minus 4 and x plus 4. And if you notice, that is correct. And what do you notice about these two factors? Well, I'm hoping you notice that they are exactly the same, except one has a minus sign between them and one has a plus sign in between them. Okay, let's take a look at this example. If we factored this using our method of decomposition, we would be looking for two numbers whose product is 36 and whose sum is negative 12. And those numbers would be negative 6 and negative 6. So I'm going to replace the negative 12x with negative 6x and negative 6x. And I'm going to leave the first and last term the same. Now we're going to group the first two and group the next two. So I could factor a 2x out of the first two terms and be left with 2x minus 3. And I could take out a negative 3 and be left with 2x minus 3. And now I have a common factor of 2x minus 3. And if I factor that out, my other factor is also going to be 2x minus 3. And you notice in this case, both factors were exactly the same. So these are two special cases. This first one, if you notice, is a perfect square being subtracting another perfect square. So we call this first one a difference of squares. The second one, where both factors are the same, is called a perfect square trinomial. Okay, so those are the two special cases we're going to be looking at today. All right, in factored form, a perfect square trinomial has two factors that are exactly the same. So in the previous example, instead of writing 2x minus 3 times 2x minus 3, I could have written 2x minus 3 all squared. And that's what this is meaning right here. Or it could be a minus b all squared, same thing, two factors are exactly the same. Let's factor each trinomial and verify by multiplying the factors together. Okay, so let's do a little test here to see if this is a perfect square trinomial, because if this is a perfect square trinomial, we do not always have to go through the decomposition method. And here's how you can test if it's a perfect square trinomial. You take the square root of the first term, which would be 2x, multiply it by the square root of the last term, which would be 3, then times all of that by 2. If you do that, you get 12x, and that is exactly what the middle term is. So we know this is a perfect square trinomial. So in order to factor this perfect square trinomial, we know both factors are going to be the same. It's going to be very simple because our test now is showing it is a perfect square trinomial. Take the square root of the first term, 2x, so that's going to go in the first term in both factors, and the square root of 9 is 3. And we take the sign of whatever the middle term is, and it's plus, plus. So 2x plus 3 squared would be the factors of that trinomial. Over here, let's do our test first. The square root of the first term is 2. The square root of the last term is 5x. And if I times that by 2, I get 20x. And this is what the middle term is. So we know this is a perfect square trinomial. So the square root of 4 is 2 and 2. The square root of 25x squared is 5x and 5x. And the sign is minus, so those are both going to be minus. So there would be your two factors. So the simple test here determines whether it's a perfect square trinomial, and if it is, take the square root of the first term. That's your first term in your factor. The square root of the second term is the second term in your factor, and the sign of the middle term of your trinomial is the sign of each of the two factors. Okay, I want you to give these a try. Okay, hopefully you had a chance to try it. The square root of 36x squared is 6x. The square root of 1 is 1. 6x times 1 doubled is equal to 12x. And that is my middle term, so I know this is a perfect square trinomial. Square root of 36x squared is 6x and 6x. Square root of 1 is 1 and 1, and the sign is plus. So those are the two factors. Again, if you want, you can multiply them out to verify that they're correct, but we know that they are correct. Here, the square root of the first term is 4. The square root of 49x squared is 7x. And if I times it by 2, I get 56x. And that's exactly what my middle term is. So now I know it's a perfect square trinomial. So 4 and 4 is the square root of 16. 7x and 7x is the square root of 49x squared, and both of those have to be minus. And if you wanted to write it as a binomial squared, you could write it as that. Okay, a difference of squares. If we look back at our first example, notice we have two perfect squares separated by a minus sign. It's going to be the square root of the first term plus the square root of the second term, square root of the first term minus the square root of the second term. And the order you write these doesn't matter because multiplication, 2 times 3, is the same thing as 3 times 2. So if we take a look at this example, 25 minus 36x squared, recognize these are both perfect squares. So it's going to be the square root of 25 is 5. The square root of 36x squared is 6x and 6x. One's plus, one's minus, and there's your final answer. Now, if you look at D, right off the hop, 5 is not a perfect square, 80 is not a perfect square, but my variables are. But is there something I can do first? Yes, I could take out the greatest common factor, and I'll be left with x to the 4th minus 16 y to the 4th. Now, I can factor the binomial as a difference of squares, and again, don't forget to bring that 5 down. So my two factors are going to be the square root of x to the 4th is x squared, because x squared times x squared is x to the 4th, and the square root of 16y to the 4th would be 4y squared and 4y squared. One's plus and one is minus. Now be careful in this one because we're not actually done, because here is another difference of squares. So I'm going to copy down these first two factors because they can't be factored any further. But x squared minus 4y squared is a difference of squares. The square root of x squared is x. The square root of 4y squared is 2y and 2y. One is plus and one is minus. And there would be the final factored form of question B. All right, I want you to take a chance or turn to try these two. So pause the video and give them a whirl. All right, hopefully you had time to try those. So again, I have two perfect squares being separated by a minus sign. The square root of 81m squared is 9m. The square root of 49 is 7. One is plus, one is minus. You're all done. Part B again, notice the variables are perfect squares, but my coefficients aren't, so look to take out the greatest common factor. So I'm going to take out a 2, and now I have a difference of squares. So if I factor further, it's going to be 9v squared. It's the square root of the first term. W squared is the square root of the second term. One is plus, one is minus. And again, I'm hoping you recognize this is still a difference of squares. So 2, 9v squared plus w squared. And now the square root of 9v squared is 3v and 3v. The square root of w squared is w with w. One's plus, one's minus. And that would be your final factored form. Okay, let's try these now in two variables. Okay. Again, we've done some of these before, but again, they were with the simple trinomials. So again, these are not differences of squares or perfect square trinomials because I have no greatest common factor that I can take out to make this into a perfect square trinomial. So we're going to use decomposition again. So I want two numbers whose product is going to be 6, whose sum is -7. And I'm hoping you realize that -6 and -1 would be that case. So I'm going to replace -7ab with -6ab and -1ab. So my first term and my last term are not going to change. But instead of putting -7ab, I'm going to put -6ab minus 1ab. Now we're going to go back to factoring by grouping. So I'm going to factor out a 2a out of the first two terms, and that's going to leave me with a minus 3b. And I'm going to take out a -b, and that's going to leave me with a minus 3b. And now you notice that a minus 3b is the common factor, so I can factor out an a minus 3b. I'll be left with 2a minus b as my other factor, and again, FOIL those, they'll get back what you started with. Okay, taking a look here, same scenario. 10 times -2 is -20, so I want two numbers whose product is -20 and whose sum is -1, so it's going to be -5 and 4. So those are my two numbers. So again, 10c squared, and I'm going to replace the middle term with -5cd plus 4cd minus 2d squared. So again, taking out the greatest common factor. For the first two terms, I can take out a 5c, and I'll be left with 2c minus d. And here I could take out a 2d, and I'll be left with 2c minus d. And now, notice I have a common factor of 2c minus d. So I'm going to factor out the 2c minus d. And my other factor is going to be 5c plus 2d. Okay, I want you to take a try at these two, so just pause the video and give these a whirl. Again, hoping you've tried this. So again, two numbers whose product is +30 and whose sum is -13. Again, those would be -10 and -3. So again, I'm going to replace the middle term with -10cd and -3cd. And the first and last terms are going to stay the same. So again, grouping the first two, I could take out a 5c. I'm left with c minus 2d. Take out a -3d, and you're left with c minus 2d. And now the c minus 2d is the same. I'm going to factor that out, and I'll be left with a 5c minus 3d as my other factor. Okay, trying the second one. Again, two numbers whose product is going to be -6 and whose sum is -5. So again, those numbers are -6 and 1. So again, I'm going to replace the middle term with -6pq plus 1pq. And oops, I should do the last one in blue again to be consistent. Minus 2q squared. Again, group, and I could bring out a 3p. I'll be left with p minus 2q. I can bring out a q. I'll be left with p minus 2q. And now the p minus 2q is common to both, so I can factor out a p minus 2q, and I'll be left with a 3p plus q. And those would be your final factors. So again, these last examples were just using a decomposition with trinomials that had multiple variables. Okay, so same process, we just have the extra variable to deal with. All right, there is your assignment for today. Okay, so you have those questions from your textbook, and we have a number of handouts that you can try. There's one there, and there's the answers to that page. And there is your chapter review for the chapter because we are done the chapter. So you can give those a try as well. And that concludes here's some perfect square trinomials. I guess I should have moved that one up first. So there's another handout of perfect square trinomials. So again, give those a whirl, and you can check the answers either in my binder for the worksheets or on the web page. Okay, good luck with those.